Hi, good evening. Myself Sudheep Kumar, Mathematics faculty. So today we are going to discuss about continuity, right? So before going to start the concept, let us see this. So here it is, Unacademy Plus. Are you a Plus subscriber of Unacademy? Do you want to become a Plus subscriber of Unacademy? If you want to become a Plus subscriber of Unacademy, first you should know the benefits of Plus, right? మనం దేనిలోనైనా చేద్దాం అనుకుంటే మన బెనిఫిట్స్ ఫస్ట్ తెలిస్తే కదా చేరాలా వద్దని డెసిషన్ తీసుకుంటాం, రైట్? So let us see the benefits. The first one is premium content at affordable price. Next, structured live courses plus dedicated live and outplaying sessions. Quizzes at regular intervals for self-analysis. So batches for complete preparation. Test series for DPPs, full-length marks, etc. with analysis. For unlimited access. So everything under single plus subscription. There are 20 plus top educators, 10 plus batches, 250 and 2000 plus lessons, and many more added every day. So if you want to become a plus subscriber of Unacademy, so please use the code SUDHEERLIVE, SUDHEERLIVE. Okay, ma'am. So we'll see the we'll go to the concept. What is meant by continuity? So today we are going to discuss about continuity. What is this continuity? So let us take the graph. It is easy to understand. If you draw the graph of a function, continuity means there is no break in general, right? So let it be considered as x-axis. This is considered as y-axis. If you draw the graph of the function, suppose if you start from this point, if you draw the graph of the function from point A to point B. So I did not lift my pen from point A to B. So there is no break between A and B while drawing the graph of the function, right? So then this function is said to be continuous in its domain. This function is said to be continuous in its domain. Suppose if we take another graph of this function, So if you see this one, so I started from C till D. So at the point at x equal to a, right? When this function is said to be continuous, the first condition is when left hand limit LHL equal to RHL equal to f of a. The value of the function is denoted by f of a at x equal to a. Hello Manita Chandra. Where are you from? Thanks for joining my session. Manvit. So LHL is denoted by a limit x tends to a minus f of x, and RHL is limit x tends to a plus f of x equal to f of a, right? Suppose if this condition is satisfied, then we will say that f of x is continuous at x equal to a. Sometimes it will satisfy only one condition. Limit x tends to a minus f of x equal to f of a. Right? So this is said to be left continuous. At x equal to a. If it is R, limit x tends to a plus f of x equal to f of a, then it is right continuous. So instead of finding the point where it is continuous, it is easy to find where it is when it is discontinuous. So the function f of x is discontinuous at x equal to a, the following conditions. Hi. One 95466. I'm using pen tab. Can you hear me? Right? So f of x is discontinuous at x equal to a. The first condition is limit x tends to a minus f of x does not exist. Are you, sir? Yeah, I'm giving the reply, just a minute. Right, and the second condition is a limit extends to a plus f of x. If it is does not exist, also we'll say that the function is discontinuous at x equal to a. Suppose f of a is not defined. In this case also f of x is said to be discontinuous, right? Next, still the other cases are, suppose the first condition is limit extends to a minus f of x. This exists. Limit extends to a plus f of x also exists. These two are not equal. Then we will say that the function is discontinuous at x equal to a, right? And the next case is limit extends to a minus f of x exists, and limit extends to a plus f of x also exists. Also both are equal, even though if it is not equal to f of a, then the function is said to be discontinuous, right? Sometimes it oscillates also. Okay, so based on these conditions, let us see this. So that the given function is, so suppose the question is given, so find the points of discontinuity of f of x equal to x square minus 25 by x plus 5, where x not equal to 5, right? So we should see that this condition is given where x is not equal to minus 5. So f of x does not exist when x equal to minus 5, because denominator is minus 5 plus 5 is 0. But here already the condition minus 5 is excluded from the domain of this function. So we should see that the function is continuous in its domain or not. So if you draw the graph of the function, for example, at x equal to minus 5, if we draw the graph of the function, so till 5, minus 5. So this also. Suppose we'll get the graph of the equation in this format. So actually, if you take from this point to this point, we lift the pen here at -5. Usually, we will say that it is a discontinuous function, discontinuous at x equal to -5, the given function. But is it discontinuous at x equal to -5? We should see that it's not discontinuous at x equal to -5 because the condition is given. We need not check at x equal to x is not equal to -5. That means except -5, we should verify that the given function is continuous or not. If we observe this result, except -5, it is continuous or not. Let us check it now. By seeing the graph of this function, roughly draw that, so we can find out it is continuous. Right, so first f of x can be written as x square minus 5 square by x plus 5. Then this can be written as a square minus b square, a minus b into a plus b by x. These two gets cancelled, so that the result is x minus 5. Isn't it? So therefore, f of x equal to x minus 5. So we can take LHL and RHL and f of a, whatever it is. It's a polynomial function, right? Polynomial function is continuous at every point. So polynomial function is continuous at every point in its domain. Right? So that it is continuous at except x equal to minus 5. So let us go to the next one. We go to the next one. Find the points of discontinuity of f of x equal to mod x minus 5 right. So the options are given. It's option A, discontinuous at x equal to 5. B is discontinuous at x equal to minus 5. Continuous at every point in its domain. And the next one is none of this. So which is the correct answer? So f of x equal to mod x minus 5 is given, right? So let us take f of x equal to mod x minus 5. Mod x minus 5 is defined as minus of x minus 5 or 5 minus x if x less than 5. X minus 5 equal to 5. Right? Is it clear now? And now find. So if you see the first one, x less than 5. F of x is 5 minus x is a polynomial function, so that it is continuous at every point less than 5. Now if we come to this part also, f of x equal to x minus 5 is also polynomial function, so that it is also continuous at every point is greater than 5. So we have to find whether it is continuous at 5 or not. Hi, rolling gaming. What marks that? Can you repeat? Okay, at x equal to 5, let us find LHL. So limit x tends to 5 minus f of x. Limit x tends to 5 minus f of x. What's the result now? So if you want, we can write limit h tends to 0 f of 5 minus h also. If it is 5 minus, the function is limit h tends to 0 5 minus x. So 5 minus x value is 5 minus h. Isn't it? So 5 minus x. So when it is 5 minus x, 5 minus h we can write. So this result is 0. Right? Now let us find right hand limit. Limit x tends to 5 plus f of x equal to. So we can see that it is limit h tends to 0 f of 5 plus h equal to limit h tends to 0. 5 plus means x minus 5. So x value is 5 plus h minus 5. Even though 5 minus 5 gets cancelled, h value is 0, so that it is 0. So f of a, in the sense f of 5, x equal to 5, right? So a value is 5. F of 5 equal to, what will get f of 5? Is x plus 5. Sorry, x minus 5. If it is x minus 5, the result is 5 minus 5 equal to 0. So what we got this result? Here limit x tends to 5 minus f of x equal to limit x tends to 5 plus f of x equal to f of 5. So we got LHL equal to RHL equal to f of e. So that it is continuous at 5 also. So it is continuous at every real number. So we can write the correct answer is, what's the correct answer? Continuous at every point in its domain. Right? Next. Okay, ma'am, who have joined in my session, thanks for joining my session. So we'll discuss briefly we discussed about the continuity. So we'll discuss more number of MCQs, different types of questions which are related to EAMCET, TS and AP EAMCET in special classes. So kindly join in my special classes. Then we can discuss more number of questions which help you to EAMCET 2021. Right? So I have the class at 6:45. So kindly join in my special class. There we will discuss only MCQs. Right? And then. So in the next session we will discuss about differentiation. So there also we'll discuss briefly concepts related to differentiation in these classes, and if you come and join, just observe the class in special classes. So I hope that mostly you like in the special classes about the MCQs. You feel you could learn something. If you like the special classes, then you could continue for an advantage. Right? So someone asked rank below 2000 in 2021 EAMCET. Yes, why not? It's possible. Hard work never fails, right? So if you do the hard work, surely you will get your dream rank. మనకి ముందు నుంచి ఎప్పుడైతే గోల్ సెట్ చేసుకుని ఉంటామో దానికి తగిన విధంగా ప్లాన్ చేసుకోవాలి. ఫస్ట్ ప్లానింగ్ ఈజ్ ఇంపార్టెంట్. మేక్ ఎ సఫిషియెంట్ ప్రాపర్ ప్లాన్ అండ్ మేనేజ్ ద టైం. Time management is very very important. These two, then it is easy to get your result what you are expecting. Right? Okay, ma. We'll meet in the next session with a few more examples, few more some different concept along with few more examples which help you to make you understand the concept as well as you can complete the MCQs easily without any confusions. So kindly join in my sessions. We'll see that. If you join in the special classes, you'll get a clear idea about EAMCET MCQs, how we are solving it, what are the tricks to play to solve the questions in a short span of time.